This is kind of my signature. I've created this talk within the last year, because believe it or not, I've been in this space for about 6 or 7 years, but I think the last year has been a year of codifying all of the things that I've learned as a designer, a design researcher, and a design leader in the ML AI space. So I've been trying to put it into something that's concrete and frameworks that people can understand about what's different about this field and how we're addressing some of the not so nice outcomes that come from humans engaging with machines. So hopefully at the end of this, you can walk away with a little idea of what design in an automated future, at least from my point of view, will look like. And I call this the birth of AI ML design, because I really do feel like we are crossing the line into a new way of doing design that is different than interaction design and different than industrial design and all the other designs disciplines that we've had before. So this is my design ethics statement. I make my students write one, and I had a student say, well, what's yours? And so I had to write my own. I was a journalist for a long time. And when you become a journalist, you join an organization called the Society of Professional Journalists. And it's kind of like a place where you learn how all the moral codes that you're supposed to follow in your profession. And when I became a designer, I was kind of waiting for that to happen. Like I was waiting for my design ethics guidebook and frameworks and card, and none came. So I started on a journey with my students actually to create my own design ethics principle and framework. And so this is mine: to amplify the beauty of humanity with design while avoiding practices that exploit its fragility. So if you don't have one, I encourage you to get on that journey to create one for yourself. About me, yes, as Christina said, I am I'm head of design for machine learning and responsible AI and machine learning governance. And I want to kind of unpack that, because I think my job kind of tells us where we are with machine learning and AI design right now. It used to be just the technology, right, of how we create models and how we create AI and ML. And now people are really thinking about, like, how do we explain those creations? And so you have something like what's called machine learning governance, where you have a separate process where you kind of analyze and audit your machine learning creations to look for things like bias and discrimination, as well as equity and some other things. And then you have what's called responsible AI, which is this whole other field of, outside of compliance and governance, how should these machine models interact with the human population, with society, with individuals, with communities. And so I'm on a meta level with my team, where we actually are the design team for the machine learning platforms. So our users are data scientists and model developers. So we design for them. So our research is really about how they do their processes. And the world domination plan is I get to embed RAI and equity principles into the model development process, right? So I really feel very lucky to be able to do that. My jam has always been end-to-end design. I love rapid prototyping. I've always kind of fallen into enterprise software design. So I've always designed system architectures and software, like APIs and databases and all that kind of stuff. And I think that allowed me kind of like to understand the machine learning and AI systems design kind of framework a little bit better. I also am an adjunct professor teaching designing ethical AI at the School of Design in DePaul here in Chicago. So this is me. I have 30 years. This is me as a baby and me in 4th grade, and then all the way up. I used to work at IDEO. I used to work at Microsoft. I worked as a journalist, both domestic and internationally. I was like doing anthropology research. Like I've had a really varied background. I've also worked with companies in all kinds of industries: financial, healthcare, human resources, automotive, worked on self-driving cars and nonprofit and government industries. So I have a really wide narrative around design and a wide narrative around technology. And I have a BA in communications and English and an MS in computer science. So I think I wrote this in Interactions magazine last year when they lovingly asked me to write a piece about what does design look in the future. That I feel like as designers, our roles will be to determine what not to design in a quest to preserve human culture, values, and rituals in our future world. I do believe we will get to a point where machines will be able to do almost anything that humans can do. I won't say everything, that's singularity, but pretty close. And I feel like as designers, we're probably in a unique position to kind of hold up the stop and wait sign. And I think if we don't take that responsibility, we will run the danger of creating products and platforms and services that actually are antithetical to human nature and human needs. And we don't want that. So here are some level setting definitions I like to start off with so everybody understands what point of view I'm coming from and my mental model. This is my favorite definition of design. It comes from design revolutionary Victor Papanek. And if you haven't read Design for the Real World, please do. Design is the conscious and intuitive effort to impose meaningful order to chaos. So again, I'm putting agency on design to have a responsibility to make sure that we are imposing meaningful order to something that is chaotic, meaning a lot of problems and issues in the world. So the first chapter when you want to understand machine learning and AI design is you have to understand data. And from the Oxford Dictionary, or data, as people say, but when I say data, I always think of Star Trek. So I just say data instead. Data is things known or assumed as facts, making the basis of reasoning or calculation. I love that fact that it says known or assumed as, because I think it really kind of sets the spectrum of what data could be. This is my t-shirt mantra. I think I'm gonna get online and create a whole fleet of these. I usually make people in an audience repeat this so that people really understand that data is created by people and people create data. We as humans have a long history of data. We have a long history of our identity being formatted in data. How tall are you? When were you born? How many siblings do you have? Like all of that is data, right? Like who you are as a person is made up of data. And the reason why I like to start with this is, especially when I'm talking to data scientists and technologists, is the idea that when we're using data to create these amazing complex models, that we're using identity, we're using people, right? Like we're not just using ones and zeros. And I think that's really important to set the stage right off the bat. And as designers who are human-centered designers, the idea that we belong in those rooms when things are being decided, because we are the people experts. And so if anything is being created with data, then that means it's being created with people, and then that means we belong. So does anybody know what this is? You guys are smart, so you probably already know what this is. Anybody? I don't know. I don't know if you can talk through the chat or not, but this is what's known as a Shirley card. And I want you guys to look at this little label right here. It says normal. What does that make you feel when you look at this and you see that word normal? I just want you to think about that a little bit. And maybe we can talk about it later. Christina, horrified. Yeah, as a Black woman, it makes me feel excluded, right? Like it makes me feel like I'm not normal because I certainly don't look like Shirley. So Shirley cards are historical in photography. Kodak started it. Kodak was the first company to go from black and white to color photography. And I don't know how much you know about photography, but I used to work at a newspaper back, that was those things that they used to deliver at your homes. I know you guys don't have those, but those used to be printed, not digital. And when you're doing a newspaper, you had to color correct, right? Because you were using plates that were combining colors to make hues rather than, having it digitized and all that good stuff. So you had to make sure that when you were taking a color photo, that it was perfectly what they call white balanced. A very interesting word there as well. So when you were taking a photo, you had to actually put a white sheet of paper in front of the camera lens to make sure that the photo was balanced correctly, so that the hues that would come out of your color photo were the right hues, were normal. But the problem was when Kodak decided that they were going to go from black and white photography to color, and they had to create a balancing spectrum for that, so that the technology could recognize what was normal and what was to the left or to the right of normal, lighter or darker. This one engineer had a calendar, and it had this woman on it, and he thought this would be the way that we could calibrate all color photos. What happened was, when they used a woman who was a white woman to normalize color photography, everybody who wasn't her skin color, who was darker than her, was basically made invisible. So when you look at old photographs, Polaroid, Kodak, whatever, this is adopted around the industry, I would look at photographs when I was growing up, and half of my family you couldn't see because they were so dark. And you would think Vox Media did a whole piece on this. It was really great. You would think okay, we've advanced in technology, light years from the Shirley cards. They really don't do that today. Well, a legacy of Shirley cards is bias and facial recognition. So you take photography, right? And so it's biased against darker skin. And so people become almost invisible when trying to replicate that in print, right? Now you move to things like LED lights, right? They're color balanced the same way, right? It's institutionalized. And so now you go into a hotel, and I put my hands under a faucet, right? And it doesn't recognize my dark skin, but my white frame, they do it and it recognizes it. And so the water comes out. And now, okay, so that's an LED. And then now you get to facial recognition software, which, by the way, is about 90% accurate. But that 10%, Black females like myself have a huge problem being recognized by facial recognition technology. And all of that lineage from the Shirley cards all the way to today, Google just released a new version of their phone, of the camera phone, that can now, quote unquote, recognize darker skin. That's been a long time in the making, but Black people have been around forever. And so I use this to kind of make a very pointed example of, we only measure what someone says matter. So data defined as biased data. So if anybody tells you that any ML or AI algorithm is not biased, I just have to challenge that, because our institutional and systematic racism, sexism, and ableism, and a lot of things go into who we are and who we define at what matters and what kind of data we want to use. And therefore really kind of starts off our process in machine learning and AI in a biased, narrow view. It's not like Black people weren't around when Google and Apple and other technology companies created camera phones, right? It's just that we weren't counted in the color spectrum. And so we only measure what someone says matters, right? And if LGBTQ people, if the US Census decides that not marking that you are of, that's part of your identity, then does that make you invisible? it wasn't until this year the US Census even thought about counting LGBTQ people, right? So I think it's really important as designers is if we want to kind of create human-centered AI and ethical AI, we really got to start at the beginning. And the beginning is the data that is either omitted and not used in models or used in a way that perpetuates systemic racism, sexism, and ableism. So this is part of my 10 commandments of mindful AI, for us to remember that this is how we start off with these systems. We're using data that's biased because we've defined it. Same with Fico scores, right? Capital One actually doesn't use Fico scores. We use information from the three credit bureaus, but we use it differently. And I think it's really important that people understand that you don't have to fall into these systematic, institutionalized data creation places. You can use data in a different way to be more fair and to be more equitable. And I like to use the Fico score because Fico was created by a white engineer in 1958 to help banks kind of decide credit worthiness, right? It's been the same formula. I won't say the same, but mostly the same formula since 1958. And a lot of people don't like to mess with it because it has institutional legacy, which inherently has institutional bias. I mean, what was going on in 1958? Redlining, people weren't getting mortgages because of their color of their skin, their sexuality, their religion. There were a lot of things that were going on in 1958 that statistically we have not vetted out of a system like Fico. So I have these examples is that data is the lifeblood of ML and AI. If you are looking to make sure that human-centered design products that are being fueled by ML and AI are equitable and ethical and take into account human needs, all that, then you have to start with the data that goes into those systems. Data and people are irrevocably linked. So all people create data, and keeping people in the forefront of data aggregation ensures more human intelligent product design. Data is integral to ML and AI. Without data, there's no machine learning, no artificial intelligence. And it's important that we as designers really understand how data is collected, how it's cleaned, how it's engineered, and how it's transformed by data scientists and model developers to ensure human-centered AI. And data practices ultimately dictate an AI user experience. So biased data creates biased machine learning models. Missing data creates bad machine learning outcomes that affect people disproportionately in different ways. And so ultimately a company's data practices will dictate whether it's a human-centered AI, whether it has a human-centered AI experience or outcome. Some terms I think you should be aware of if you're not already, if you want to go into this field, is unstructured data. This is data that isn't easily labeled or stored or categorized, which means we have more opportunities as humans to influence how that data is engineered and read. Some examples include text and PDF, images, Word documents. Then we have structured data. This is cleaner than raw data. This has been labeled, this has been categorized, like speed limits, right? Things like that. And it usually is ready for data analysis or visualization. It's also, I have a little stop sign here because I think it's also an alert place when it's structured data. It's also biased data because it comes, because somebody has to label it and categorize it and give it meaning. So structured data goes from just kind of loose data that somebody, right, some process categorizes it, and then it has meaning, right? And so you have to really look at those meanings when people structure data. And then there's explicit data. This is information that is provided intentionally by people. So I sign in, I log up, I fill out a registration form. You know exactly why I'm putting that data in. Then there's implicit data. this is information not provided intentionally, but gathered from available data streams, either directly or through analysis of explicit data. So for example, when you click a thumbs up, it's implied that you like that content, right? I also have red stops there because a lot of implicit data is used to make what I call contextual leaps. And without qualitative data to back that up, you don't really know what's happening when that data is created. It's really important that data is contextual. It's not just something that you collect and then shove into a model, right? You really need to understand where that data comes from and why it was created. So facts to remember, again, all data is created by people. So don't divorce people from their data. One of the biggest sins in unethical AI, or what I would call not human-centered AI, is the sin of omission. So creating a model that makes decisions that has a lot of missing data. So if the US Census was to create a model to decide who in the LGBTQ community could receive benefits, for example, I would question that, because those folks weren't included into census counts until this year. So there's a lot of missing, last year, there's a lot of missing data variables there. And then lastly, and the number one commandment from Ovetta 10 Commandments of mindful AI is data is not truth. That is not the unbiased, unchallenged input as advertised. It's the version of the truth that depends upon who's collecting, engineering, categorizing, and using it. Data is always contextual. It will never stand on its own as just truth. Because data is not truth, we have to work to detect and reduce bias in it, right? That doesn't mean our machine learning models need to perpetuate the historical biases that come with things like medical history or medical experiments, right? Lots of medical experiments have been done, but most of them have been done on men, white men for sure. So how do I know that experiments for diabetes medication, for example, which disproportionately affect people of color, is really the right experiments for me to have good outcomes on my health as a Black woman? I think ML designers who work with data scientists can help to discover, detect, and reduce historical biases in data collection before it gets into the model. That is so important. And that is part of machine learning experience design. If you want to be a designer in this area, one of the responsibilities is to see what is going into those models and to detect if historical biases are being fed into a model. I think designers could pair, our normal HCD methods with bias reducing mathematical methods to reduce bias before it becomes a model outcome. I think it's important to acknowledge and announce, make data inputs and model outcomes more of a glass box than a black box. Announce the ingredients and the recipe that you're creating, right? That's has to do with explainable AI, which is what we're working on. Be upfront about weak data and data engineering. Not all data is good data, and that's okay, but you need to kind of say that in model outcomes when you're evaluating model goodness. And explainability is a legal requirement, but traceable and publicly audible without IP violation is a higher and better bar. So I should be able to do an audit on your algorithm to see how it made its decision. Because data is not truth, wrong data will be occasionally used. Use this as an opportunity for design. Don't just abandon eliminating biases because we know it's impossible. ML designers create experiences to help users provide model feedback. That's one of our biggest charges, is to design ways for humans and machines to have a reciprocal relationship when they're going through the machine learning powered experience. New, better data helps to neutralize the effects of bad data. So you can't just set it and forget it. You can't just use one data set over and over again. There's a thing called model drift, where the longer a model is in play, the more accurate it can become, and you need to detect that. So this is a nerd alert. Now that we've gotten through data, I'm just gonna go quickly about how it's used in ML and AI, and then go into ML and AI capabilities. and give you kind of like an overview of kind of the nerdy side of this world. Hopefully this won't be too boring for you guys. Machine learning is a category of artificial intelligence in which computers learn to achieve a desired outcome by applying problem-solving rules automatically after being trained to do so. Data is fuel for all machine learning models. Data scientists use algorithms to use data to train and teach machines to solve problems through models. Algorithms are the lifeblood that carries the fuel, allowing machine learning models to sense, act, and learn. I've been told that data scientists hate when people explain machine learning as replicating the human brain. So I'm gonna have to switch that out. But basically, I'll go through the process of it, and then you'll see how machine learning works. I think it's really important to understand that we create algorithms every day. If it's raining outside, you have a rule that says, I'll go grab a hoodie or an umbrella. That's just a simple rule that happens every time, right? And that's an algorithm. Socrates is said to have created the first algorithm, right? It's analog, but it's still an algorithm. And this is how the human brain processes information. If you're ACI, you've seen this several times. We have internal, external stimuli. It goes into our brain. We reach back into our sensory information, sometimes short-term, which is always working, sometimes long-term, which takes longer to get to, thinking fast and slow, those kinds of things. We recognize, oh, I've seen this before, looks like a flower, it's yellow, must be a dandelion, or must be a flower that looks like that, or it's red, maybe it's a rose, those kinds of things. And then we go through a series of thought process to decide how we're gonna behave. Do we pick it? Do we leave it alone? Do we walk by? Those kinds of things. Eerily familiar on the data, on the development of a model development process of a ML model. We get internal or external stimuli, usually data from historical data, or data from ambient, like the environment. It comes in, that data is validated and recognized. It's been trained on that data, so the model kind of goes back into its memory and say, oh, I recognize this data. I've got rules to apply to that data, and so it behaves in that applicable way. And then as the data scientist goes through the process, it kind of repeats this process several times to get to a good model goodness score, meaning that the model is replicating the results that are asked for at a high accuracy rate. Accuracy is only just one way to determine model goodness. And then it trains it again on data it's never seen before, just to make sure that they can validate the results. And then it goes through the process again. This is the model development process. Machine learning is used in anomaly detection, classification models, classification models, imaging, dog or a cat, recommendation models, Netflix, what kind of movies do you like? These are examples of machine learning in the real world. And then artificial intelligence is just kind of like an umbrella of other ways to do machine learning and other types of algorithmic based technologies, neural networks, deep learning, all of that. And the way that I like to separate, and this line is becoming more blurred every day, it used to be that machine learning just did historical data and artificial intelligence could do real-time contextual data. But now machine learning algorithms have become so strong, they can do real-time contextual data as well. So I don't actually know where the line is going, but now they have something called machine intelligence, which is the intersection of artificial intelligence and machine learning. And these are what we call the deep neural networks and the deep learning networks that places like Google and Facebook and even some other places are getting into. I think the key difference is that artificial intelligence really transforms the information, right? It's transforming it so that decisions or behaviors can be made. It's dynamic, right? Computers are using their environment to do tasks rather than depending on historical data. And when paired with other technologies like IoT, AR, VR, you can really have a machine see and hear and taste and smell, like write poetry and smell bread and taste sugar and see the drive. It really kind of like exponentially creates new capabilities for AI and ML. I like this kind of like human machine kind of like mirrored mirrored slide on capabilities for AI and ML. We see AI powered machines can see automatic cars, Google search classification, facial recognitions. We hear AI can use auditory sensors to replicate sound and to hear and to process sound. We speak, natural language processing can have us have contextual conversations through Alexa, Siri, Cortana, Eno. We act. Automation allows robots and dancing robots from Boston Dynamics, which are really my favorite. And we make decisions. So recommendation models, Netflix, Facebook, Twitter. So we're getting close. So some key AI terms: algorithms, machine learning, deep learning, does not require step-by-step programming and can make decisions on its own. Narrow AI is also known as weak AI. This is where we are pretty much at. And then there's generative AI. This does not exist, but it does. And this is GAN. This is when you see those really amazing like art replicas that AI can generate without ever going to art school. It's kind of interesting if you've ever seen it. And then of course, AI singularity. And this is really when AI machines become self-aware. This is the stuff of, iRobot and Octavia Butler and some other folks. Now, I'm fairly certain this does not exist, but I'm not gonna, bet the farm on it. This is all how we use AI in the real world. It's everywhere. I think there's a quote that like 75% of Americans have some kind of AI powered device or product or service. These are the capabilities. And I think it's really important to know the limitations. As designers, this is where we're going to spend most of our time, which is kind of a bummer. We will be the negative Nancy, right? Like we are definitely going to be like, yes, AI could do that, but should it, no data, no dice, right? So when I think about the right applicability or desirability of AI, I think about what data is it going to be fueled upon. And if there's missing data categories, then I have to think it's kind of suspect. Garbage in, garbage out. I also think about AI and ML being applied to systematic and to being applied to systems that have systematic racism in them, like law enforcement, right? It's a red flag to apply AI and ML to a system that has systematic problems with its data, including law enforcement. HR is another space. There are a lot of different places that you have to be really careful when you're applying ML and AI. Nuance is the enemy of machine learning and AI. Like it's very binary, but individuals aren't, right? Like we're intersectional human beings. And so we really need to really kind of scrutinize when we're using ML and AI for human engagement. And ML and AI is meant to replicate human rationality, but in reality, humans are keenly irrational. So this is just an example of AI smelling. A friend of mine who I worked at when Microsoft built this smart device to smell. He's Parisian, French. His name is Benjamin Cave, and he wanted a better way to see when his bread was ready for. Oh God, I was slipping. Ready for baking. Proofing. Yeah. And he developed a way. He had a tiny ML and he had a Raspberry Pi and he put it together. And people were like, oh, wow, how can AI smell? Well, smells have a combination of chemicals, right? That is that can be numerized, right? Like you can have certain kinds of combinations that creates things that that you can smell. And so once you feed those into a microcontroller that has an AI model development component, the smart device can detect different nuances in the numerical makeup of the smell. So now he built something that can smell different whiskeys, it can smell coffee, it can smell bread. It's a pretty cool thing. And a 14-year-old used his invention to help build something that could detect different smells and illnesses. It's kind of interesting. So what does all this mean? I think quickly here, I think it means we have to redefine what design and research is in an automated future. And here's my why for that. And I'm totally challenged on this, but over the years, I've come to say that we can't do things in design and research the way that we've done in interaction design if we want to create better human-centered AI products. So the current technology we have has a user who controls the device. It's usually in a single agency. Sometimes it's a communal thing, but mostly it's like me and my iPhone, or me and my controller, or me and my television, or whatever we're doing. The interaction is usually one way, even if it's in a group way. The machine is interacting with me in a way. It's usually a one-way street. Technology is task-based, right? I want to do this, so I'm using the technology to do X. And it has affordances. All of my screens are looking the same. I know where the exit button is. It's pretty familiar to me. Even if I've never seen this mobile device before, I can probably figure it out, right? Because the device interacts with me in the same consistent way. And it's static, right? The device performs tasks in the same way. It doesn't really change it. Yes, there's updates, but I know I'm gonna push a button, right? I think with automated or intelligent system technology, the difference is the user and machine can both be in control. They can be in control simultaneously. They can be in control at different times. And that presents a different flow for experience design. The context of use is multi-agency. So you have the user, you have the device, who are both sentient, but you also have an ecosystem of other devices that can talk and engage and have relationships. So you have a self-driving car and the driver, and you have another self-driving car and driver, and there's the ability for them to all kind of have engagement in this intelligent ecosystem. Interaction is at least two-way, right? Like I can talk to the machine and it can talk back to me with a sentient understanding of what I'm saying. Technology use is decision-based, right? So the machine exists to make decisions, right? Not just to do tasks. And technology affordance can change over time, right? So when I first get my self-driving car, I may want to restrict a lot of experiences with it because I don't trust it. But after I've been driving this car for a while, I may want to change that spectrum of autonomy for the car. So the affordance can change over time. So what does that mean for an experience designer? And technology is dynamic. The machine learns and performs differently with new knowledge. And for that means my engagement will be different with the machine over time. So as designers, we have to think about that long tail experience design that isn't the same when the system, the machine, and the human are first engaged. What does that look like for experience design when we want to change that over time, right? So I think we currently use methods that aren't future-oriented enough, right? So it's really speculative. Speculative research is different. It's difficult with current UX, like interviewing and stuff like that. People don't know what kind of Stargate they want. Research needs to be more dynamic, not as static. So we can't just interview people once and think, okay, we've got confidence in design direction. And research has to go beyond single agency framework and consider like ecosystems, multimodal AI environments. So we got to go beyond usability and desirability. I think we have to seek unexpressed rituals, cultures, and values in irrational practices that humans do when they're engaging with their environment. We can't just automate those out, right? Because, for example, when I was working on this automation driving project, self-driving car project with Ford, one of our recommendations was not to take the steering wheel out, which was technologically like illogical because you didn't need it, right? Because the car could drive itself. But humans have this deep psychological need to control their environment, and they need to extend that control with their hands, right? And so if you don't have a control there, the people freaked out. It was just their mind cognitively couldn't really comprehend that the car was moving without them moving it. So how do I combat kind of like what I saw was a lack of methodology for ML and AI design? I found inspiration in things like design anthropology. Design anthropology seeks to understand how the processes and artifacts of design help to define what it means to be human. It's just the other way around. Instead of looking at humanity and trying to make it fit with design, you're looking at the design of the human and seeing if you can design things that fit into humanity, right? Design anthropology is a method of research that focuses on how design translates human values into tangible experiences. So how do you design trust? How do you design understanding? How do you design privacy? Those kinds of things. It combines ethnographic field work, but it's iterative and it's both reflection and action oriented. It's less reliant on observing current states and employs things like simulation, mock-ups, props, and tangible interactions to explore futuristic and speculative design. It's definitely co-participatory. It requires the participant of users to really get at understanding of rituals and values. And it's more scenario based. So I use a lot of games, performances, enactment. And teams are transdisciplinary. So each member is working together to create new conceptual, theoretical, and methods for innovation. So that means designers, data scientists, engineers. My team at Capital One, it's made up with people with backgrounds in physics and engineering and design and education and sociology and anthropology. It's not just made up with people with HCI degrees. So design anthropology has transdisciplinary characteristics. It requires that co-participation, and it's research-led design, and it's iterative. Research is design and design is research. There's no like concrete phase between the two. And we use provocative prototypes and simulations. We put people in scenarios so that we can understand, because this dynamic nature of ML and AI, we don't know the answers to many of the questions that we have. And the only way that we can get more confidence in our design directions is just to try to put people in futuristic scenarios. So here's how I think we're gonna evolve as designers. We're gonna kind of adopt a more hands-on, simulated, futuristic research methodology to figure out what we should be designing in this area. And I think we'll have a broader framework of our design. So we'll look at people, individuals, and systems rather than with a device, right? And then we'll have multidisciplinary teams, right? Like we'll hire diverse designers from a wide range of backgrounds, and they won't be just designers. There'll be data scientists, product managers, engineers, janitors, people with all kinds of different backgrounds who bring mental models to bear. And so it's design today is human-centered. It focuses on people's needs and it counteracts adverse effects. People really forget that in the ISO definition of HCD. I think tomorrow we'll have more pluralistic pluralism in design direction will shift from universal, and we'll have like 15 different journeys that a person can go through that we could customize and design. And automation will help us to do that. We'll go, the type of data collection and analysis will afford that kind of individual customization at a massive scale. The role of designer would kind of lose its coveted elitism and apply to people with skills not often connected to design, engineers, anthropologists, hairdressers, because the pluralism will demand intersectional designers. I believe we'll move from device and individual to human-machine relationships. This ability to hyper-customize will push designers beyond our agency model of interaction design to consider how humans and machines have a cooperative relationship together as the pinnacle of that experience. So really learning, having the human teach the machine what she or he or they want, rather than us designing a journey for them that they all must go down. And I also believe we'll hit machine agency and autonomy. Designers will have to consider the agency, not just of the humans, but of the machines and the ecosystem within which they operate. This is like my way out moonshot stuff, so I know it's kind of crazy. And we'll redefine design. We'll integrate data science design to develop intelligent products that improve people's everyday lives. This is my definition of machine learning experience design. And it'll be transdisciplinary. We'll have explorers, we'll have builders, we'll chase moonshots, those Looney Tune ideas. That would be our wheelhouse. We'll go after what seems impossible. As a designer, we'll be more interdisciplinary. We'll have a bias towards building things and just getting people in environments rather than thinking or conceptually talking about things. And we'll be forced to make abstract things like trust and value concrete. We'll treat data as a stakeholder, we'll be less design-centric, and we'll have an interdisciplinary focus, which means we'll focus on keeping people and data together, understand the data as a design tool, recognize the right applicability for AI and ML, and understanding the real-time dynamic nature of ML and AI, and focus on building to learn rather than our designer intuition. And really encourage participatory design, co-design with people impacted by these products. I won't go through this because I don't think I have time, but this was a project that I worked with the data scientists and researchers and designers on redesigning the outpatient experience for kids at a pediatric hospital. And I think what I really want to point out here about what was different about this was that we defined data and systems as stakeholders really early in this process. So definitely we went out and did qualitative interviews, but we also collected like 3 years of employment data and started exploring and looking at that data, just like we were exploring and talking to patients and their families. We integrated data and field research, exploration, and synthesis. So while the data scientist was doing exploration, he was putting that visualization in the project room, and we as researchers and designers were asking very inquisitive questions about what he was seeing. We were talking about what we saw in the data. Same thing with the data scientist coming to us. He conducted qualitative interviews with folks. And that kind of mix of mental models was really great for us to get at what I call parallel synthesis that comes from different points of view to come together to have a better insights. And so these data-infused research insights allowed us to discover better design opportunities. On the right are my qualitative notes. On the left are the quantitative notes. It's so great how they kind of like came together, and it led us to this notion of variance and how we could design for that. And some methods that we used were data people journey mapping. This is mapping data and people along your journey mapping experience. Systems mapping, where does the data come from? Where is the data created and transferred, and by whom and what? and doing, debriefing systems and data interviews together, as well as qualitative interviews, and creating what does that mean moments where the different disciplines can come together and ask about their methodology. We were able to illuminate systems challenges rather than individual challenges only, right? When you think about the user pain points, we were able to think about the user's pain points in the context with the system's pain points that allowed us to redesign the ecosystem in a better way. And we used lots of simulations to test different design outcomes and scenarios. This is one of those simulations. The kids loved it. We just basically redesigned their whole experience of checking in and figuring out when they were going to their next appointment. Yeah, that's it. I think I left like 6 minutes for questions.
Oh my gosh, that was fantastic. And while we're waiting, I've got to say, one of the things, we're both educators here. One of the things I think is hard to do is teach people how to think about time. So you talked earlier about, when you first get in, you won't trust the car, but then over time you start building that trust, and eventually you start being willing to, hand over more things. And I think it's really hard to get people to stop thinking of a moment and get them.
Yes. Yeah, they have to think about a spectrum, right? And you have to design for that. As the car gets smarter, should the experience change, right? And sometimes you need the user to teach you that when they're ready. You can't just say, all right, I'm gonna make the change happen. And one of our principles, our design principles with that was design for the transition state, not end state. So when you're designing with an autonomous vehicle, you want to make sure you don't miss the transition where it goes from car to human or human to car. A lot of people designing for the end state, right? So now the car is in control and you design the experience, or the human is in control. But really it's about that transition when they switch control. Okay. That's the real experience you want to design.
I don't want to get too pragmatic, and I know John will interrupt me if there are other questions, but are there some techniques that are particularly well suited to making those kinds of plans? You mentioned journey maps, they've become fairly standard.
Yeah, I think the thing about the journey map is, and this is an alignment that I got from our students, is the journey maps that we do are very different because they're actually not the user journey. It's the systems journey. And so you have to think about the user as within a journey rather than the journey that the user goes on. And it's a nuance in how you do those mapping. But if you get that nuance, then you really understand how to change the design. And I think I like to use an example of ordering a pizza because you can map out that journey pretty easily. Yeah. But online. But then when you go to map it, you're really going, okay, how do they get the price of the pizza that they want? How do they decide what kind of ingredients? And all of that stuff doesn't come from the user. It comes from different places within the system. And so now you're designing around a user so that they can have the experience that they want. And so now you're designing beyond what the user wants and what the system can do. So you're thinking in terms of architecture, databases, where the data lives, who has access to that. Like that needs to be part of the design.
That makes sense. You'll just let me know, right? Okay.
Yes,
so
far no questions.
Okay.
Not in the
and I don't see anything on chat, so we're good. So I'd like to dig in more into the ethics side of it. Gosh, I want to ask you so many questions, like how did you get into ethics, but also how do you bring ethics into the work process?
Yeah, and I think, first of all, I try not to use the word ethics, but I think it's because ethics is contextual, right? Like, like my ethics in India, my ethics of the way that I operate in America is one way, And I've been to 65 countries, and I can tell you that if I go to other countries about certain things are allowed that I wouldn't do here in America, and it would be completely ethical over there. I think what we want to do is to incorporate do no harm, right? As much as possible, and whatever that means, right? Like I'm not defining that, but I'm just saying like that's the way we want to think about when we're trying to do human-centered or responsible or whatever. Like I think it's really good to just say, hey, we're going to start off with acknowledging that there could be harm here. So what kind of harm does that look like? So we do harms modeling, right? This is the UN kind of like you take the UN security needs that they say everybody needs. It's like security, identity, privacy, economic, access to economic freedom, those kinds of things. And you do an exercise that goes, if I create this technology, how does it not only harm a person, but in these individual categories? Who will it harm economically? Who will it harm identity-wise? Who would it harm? And you may find it doesn't, but you need to look at it in all of the intersectionality there, like on a global kind of system scale, rather than just like, is one person going to be hurt by this, right? So when we talk about ethics, I think what I really am talking about is being mindful. How mindful can you be? That's why I call it mindful AI. So I'm really considering all the different things that can happen with this model.
Thank you. I have 1,000 questions, so I wish you weren't remote, but hopefully our paths will meet again. And
question in the auditorium.
Oh, wonderful. Okay.
Hi. And I wanted to ask, so I'm not a CS major, but I know a bit of like ML techniques, and like a lot of it comes down to like data and probability. But when it comes to like more I would say qualitative data, it's a lot harder to capture them and make it AI or like machine learning, algorithms or whatever it is. And I think a lot of it right now, like nowadays, has been transiting from like actual data to human relations and emotions, and especially in this in this post-pandemic era when people actually appreciate human relationships a lot more. So I mean, how does like a company like yours like actually look into this more human relations or like emotional part?
Yeah, I love that you asked this question because this is exactly what I'm wrestling with right now. And so here's how I talk to my company. So what a lot of people don't really understand is that banks are heavily regulated. And when we talk about regulation, non-fair lending practice, discrimination, all that extends to our models, by the way. So we have a higher bar or burden, I won't say burden, but a higher bar of fairness and explainability and all that kind of stuff because we're banks. And so all the things that we were doing in anything that we did in our practices, it extends to our technology, by the way, and we're audited by that. But I talk to my risk officer, my chief risk officer all the time. We have definite indicators that we use to see if our models are, privacy, security, fairness, money laundering, all of that. We are creating indicators that I call the human value index risk, or the human engagement risk indicators that aren't in our normal risk factors, right? That's what we're creating. They're new values that we're looking at that says, what is the risk of this model when it engages with a human? And the human has automation bias, or the human has availability bias, or the human. So now we're taking what we understand about human cognitively, the cognitive biases we're having, and we're creating indicators from that to say, and this is Ovetta's term, but it's the human engagement risk. So what are the human engagement risk indicators that we need to actually look at in our input variables when we're collecting data, when we're creating features, when we're creating models? Completely new stuff.
Yeah, and I think on top of that, okay, I guess there's no question for now, but I think on top of the things that you say, like, but who is the right person or the right team to say, like, this values is the right values? Because, like, I don't think, like, yeah.
And that's why I say the teams have to be transdisciplinary, because it can't just be the data scientist saying that.
Yeah.
What does he know about
Exactly.
sociology?
Yeah.
Like, what does he know about how humans congregate?
Yeah.
Or how
Psychology.
humans, or psychology, like automation bias was one I brought up to a data scientist who created a model where we're trying to make decisions about XYZ. And I said, look, the human will be in the loop on those first 9, 10 times, but if the machine doesn't make a mistake, the human will drop out.
Yeah, because, like...
And that's exactly what happened with Uber's self-driving car. She had been in that car for months, never had a mistake.
Yeah.
She just checked out, right? Because we tend to have an automation bias. We trust machines that don't make mistakes. How often do you trust a machine to get your checkbook right?
Yeah.
Right? You don't go around auditing your digital bank account.
Yeah.
So I think these are people who understand this need to be in the room with people who are building this stuff, right? And so, like, for example, if we build a model that decides whether we're going to sue somebody for collections, I'm like, we need to have somebody who has been sued for collections in that room.
Yeah. The value of empathy is really, like, very important in these days.
And not just
especially
empathy, but experience. Like, I want the person who's been through that in that co-designing, which is why I say co-participatory design, the role of designer will change. It will just be people who are going to be impacted by these models, right?
Yeah.
Right alongside the person making the model.
Okay. Thank you so much.
Yeah, thank you for that question. I think it's very pertinent.
Thank you so much. We're over time, which is kind of wonderful, but I thank you so much for all your time and thank you for this.
Thanks for asking me. I enjoyed it.
Bye.
Bye.